Hi, this is a new video about linear differential equation for grade 12 GS and LS. This is the part 5 of a set of videos about differential equation. In this video we will talk about the differential equation of second order. First, let us start by the form of differential equation y double prime equal g of x. To solve this differential equation, it's very easy to integrate successively, to make two successively integrations. Okay, let us take the example 1. We have y double prime equal x squared plus 2x minus 4. First we do the first integration to get y prime. Integral x squared is equal x cubed over 3. Integral to x is equal x squared, and integral minus 4 is minus 4x plus c1. Now we have y prime, but solve the differential equation. That means we have to find y, so we have to make another integration. We calculate the antiderivative of this function now. Integral of x cubed over 3, we take the 1 over 3 outside the integral. Integral x cubed is x4 over 4 times 1 over 3, we get x4 over 12 plus x squared. The integral of x squared is x cubed over 3 minus 4, x is x squared over 2 multiply by minus 4, so we get minus 2x squared plus c1x plus c2. Let us take this differential equation now. Y double prime minus x minus 2 equal to 0, and we have here two initial conditions. Denote by that, if we want to solve, if we want to find the particular solution of differential equation of second order, we need two initial conditions, because we have two constant of integration, as we see in example 1, c1 and c2, and we need two initial conditions to calculate these two values. Okay, first let us find y double prime. Y double prime is equal to x plus 2, is equal to x plus 2. So now y prime is equal integral x plus 2 is equal x squared over 2 plus 2x plus c1, and we want to find y. Y is antiderivative of this one, so antiderivative of this one dx is equal to x cubed over 6 plus 2x. Integral of x is x squared over 2. We simplify the 2 and the 2 to get x squared plus c1x plus c2. This one is the general solution of this differential equation. Now we want to find the particular solution by using the initial conditions. We have f of 0 equals 0. We replace x by 0 and we put the answer equal to 0, so we get c2 equal to 0. Now we have f prime of 0 equal minus 1, but this function here, this one is y prime, so it's equal to f prime x. Okay, f prime of 0 equal minus 1, replace here x by 0 and put the answer equal minus 1, we get c1 equal minus 1. We have c1 and c2. We replace c1 and c2 in the general solution to get this one, which is the particular solution of the differential equation, this one or this one. Okay, let us take another application. We have y double prime minus 2x equal to 0. We find first y double prime is equal to x plus 5. Integrate first time, we get x squared plus 5x plus c1, and another integration to get this one. Very easy to check by yourself. Okay, let me take now another differential equation, y double prime minus x plus 3 sine x equal to 0, verifying two initial conditions, f of 0 equal 5, f prime of pi over 2 equals 0. First, we remember that the derivative of sine x equal cosine x, derivative of cosine x equal minus sine x, and the antiderivative of cosine and sine. Okay, we have y double prime equal x minus 3 sine x. Y prime is the integral of this one. Integral of x is x squared over 2. Integral of minus 3 sine x. Integral sine x is minus cosine x. And we have minus, so we get the plus 3 cosine x plus c1. Now integral, another integral for the y prime to get y. Okay, x squared over 2, we get x squared, integral of x squared is x cubed over 3 times 1 over 2, we get x squared, x cubed over 6. Integral of cosine x is equal sine x, so 3 sine x plus c1x plus c2. Now we have to use the initial conditions to find c1 and c2 and to get the particular solution. Okay, f of 0 equal 5. Replace x by 0. Sine of 0 equals 0. Here is 0. So we get c2 equal 5. F of prime x, this one is f of prime x. Replace x by pi over 2 and put the answer equal to 0. Cosine of 0 equal, cosine of pi over 2 equals 0. Here we have pi squared over 4 times half. So c1 equal minus pi squared over 8. We have c1 and c2. We replace c1 and c2 in the general solution to get the particular solution. This one is a general solution of the differential equation, and this one is the particular solution. This one is the particular solution. Let us take another application. 2y double prime plus 4x minus e to x equal to 0. Verifying the initial condition f of 0 equals 3, f of prime of 0 equal minus 1. First, we have to find y double prime. Y double prime, we take these terms to the second member of the equation and we divide by 2. Now, we have the rules of integration here. Integrate this differential equation to get y prime. Integral of minus 2x is minus x squared. Integral of half e to x is equal, by using this formula, is equal 1 over 4 e to x because a is 2. Okay, now we have y prime. To get y, integral this expression. Integral x squared minus x squared is minus x cubed over 3. Integral of this one, we keep 1 over 4. Integral e to x is 1 over 2 e to x, and we have 1 over 4, we get 1 over 8 e to x plus c1x plus c2. This one is the general solution of the differential equation. And now we have to find the particular solution by using the initial conditions. F of 0 equals 3. Replace x by 0 here and replace the answer equals 3. So we get c2 equal 23 over 8. Okay, f of prime x, this expression here is f of prime x. Okay, we have f of prime of 0 equal minus 1. Replace x by 0 here. Okay, e to x is 1. Okay, e to x, because x equals 0, e power 0 equal 1. Okay, so we get c1 equal minus 5 over 4. So finally we have c1 and c2. We replace c1 and c2 by their value here to get the particular solution of the differential equation. And now let me take the another differential equation, the linear form of the differential equation. A y double prime plus b y prime plus cy equal to 0, where a is not 0 number. Okay, to solve this differential equation, usually we write the characteristic equation of the differential equation. The characteristic equation is an equation of second degree where the variable is r. Okay, we use the coefficient of the differential equation to write the characteristic equation. This one is a quadratic equation. Quadratic equation of second degree. We can solve it. If we have three cases. If the equation, the characteristic equation, has two roots, c1 and c2, r1 and r2, the general form, this one is to memorize y equals c1 e r1 x plus c2 e r2 x. This one is the general form of the differential equation. If the equation admit a double root, y equal r1 equal r2 equal r, so As we say, if the differential characteristic equation admits to one double root, so the general form, this one is to memorize y equals c1 plus c2x e rx. R is the common value of the double root. Okay, if the characteristic equation has no real roots, if the roots of this equation are two complex roots, okay, the characteristic equation have characteristic has the root, the coefficient of the characteristic equation are real numbers. So because they are real numbers, so the solution, if they are complex, will be two conjugate numbers, two conjugate complex number. So the first one is alpha plus I beta, and the second one is alpha minus I beta. Okay, the general form of the differential equation in this case will be y equals c1 cosine beta x, where beta is the imaginary part of the complex number, of the complex solution, and c2 sine beta x times e alpha x, where alpha is the real part of one of the roots of the differential of the characteristic equation. Let us take examples. First, let us remember the rule. This one is the characteristic equation. If we have two roots, this one is the form of the characteristic equation to memorize. If we have one double root, this one is the rule. If we have no roots, the roots are complex, so this one is the form of the general solution. Examples. Example 1. If we have this differential equation, okay, we write the characteristic equation. The characteristic equation will be r squared minus 3r minus 4 equal to 0, because replace y double prime by r squared, y prime by r, and minus 4 equal to 0. Okay, let me use a calculator. This one is a calculator. Okay, menu A, polynomial, degree 2. Okay, we have the roots here: 1 minus 3 minus 4, 1 minus 3 minus 4. Okay, the roots are 4 and minus 1. So the roots are 4 and minus 1, and we write the general form of the differential equation: y equals c1 e r1x plus c2 e r2x. Example 2, this differential equation, the characteristic equation is r squared minus 4r minus 4 equal to 0. Okay, this one is differential characteristic equation has double root, r1 equal r2 equal 2, and the general solution will be c1 plus c2x e rx, so e2x. This characteristic equation here, this general this differential equation, I mean the characteristic equation here, I have a small mistake, because the characteristic equation will be r squared plus 2r plus 5 equal to 0, not r squared minus 3r minus 4 as this one. Okay, so by using calculator, let me take a calculator. Menu, equation, polynomial, second degree. We say the differential, the characteristic equation has coefficient 1, 2, and 5. So you can see the roots, they are minus 1 plus 2i and minus 1 minus 2i. Okay, in this case, this one here is alpha, and the positive imaginary part of the complex number, we call it beta, and the general solution will be c1 cosine beta x to x plus c2 sine to x times e alpha x. Let us take another differential equation. Y double prime plus 9y prime minus 22y equal to 0. Verifying the initial condition f of 0 equal 5 and f prime of 0 equal minus 1. We write the characteristic equation first. R squared plus 9r minus 22 equal to 0, and this characteristic equation has two distinct roots. So the general form c1 e r1x 2x plus c2 r e r2x minus 11x. Okay, and now we have to find the particular solution. F of 0 equal 5, so we replace x by 0 to get e power 0 is 1, so we get this this equation of two variables. F prime x, we can make the derivative of this one. Derivative of e to x is equal to 2e to x. Derivative of c2e minus 11x is equal to minus 11 c2e minus 11x, and we replace x by 0 to get this another equation of two unknowns. By using calculator, we can get c1 equal 54 over 13 and c2 equal 11 over 13. And this one is the general form of the differential equation. I have here two other examples. The characteristic equation is this one. This differential equation, this characteristic equation has complex roots, alpha plus beta I and alpha minus beta I. Alpha is equal 4, beta equal 2, and by using this root here, c1 cosine beta x plus c2 sine beta x e alpha x. Okay, this differential equation is the last one. The characteristic equation is this one, has the double root minus 1 over 4, and we use for this one we have to use this formula. Okay, and this formula will be used here. Y equals c1 plus c2x e rx. Okay, thank you to see this video.